In this video, we're going to learn how to find the missing lengths of polygons given the area. We've got 4 examples: a parallelogram, a triangle, a trapezoid, and a rhombus. We're going to start off with our parallelogram. Find the height of the parallelogram. As you can see, it's missing. We start off by writing the formula for area of a parallelogram, which is area equals base times height. I'm going to draw a dividing line because we're going to be working it like an equation. So we're just going to fill out the missing information that we do know. Do we know the area? We do. It says so right here, area equals 187. So we're going to replace A with 187. Do we know the base? We do. It's 17 centimeters, so we're replacing B with 17. Do we know the height? We don't. So we're going to keep it as H. I'm going to rewrite this equation. 187 equals 17 times height. And now it looks like a regular equation. 17 times what equals 187? The inverse of 17 times h is to divide by 17. So what we're going to do is, to get h by itself, we divide this by 17, which means we have to divide the other side of the equal sign by 17. The 17s cancel each other out. You're left with h, or 1h, and that equals 187 divided by 17, which is 11. So our height is 11 centimeters, and that is our final answer. For our next example, we've got a triangle. So we start again by writing the formula for area of a triangle, which is A equals base times height divided by 2. Let's fill out the missing information. Do we know the area? We do. It's 52, so we're going to write 52 in place of A. Do we know the base? We don't. So we're just going to leave it as B because we don't know what it is. Do we know the height? We do. It's 8. So we're going to replace H with 8, and we bring down the divided by 2. Let's rewrite our equation. 52 equals B times 8 is 8B over 2. Now I'm going to do something a little bit different here. I can multiply both sides by the reciprocal because we've got a fraction, but I think it's going to be easier to reduce because we know that 2 does go into 8. We can reduce, we can replace 8 with 4 because 2 goes into 8 4 times. 2 goes into itself once. And so this side doesn't change. It's 52. 4 times b is 4b over 1. 4b divided by 1 is just 4b, so we're just going to write 4b. We don't have to put over 1. Again, it looks like a regular equation. Inverse operation is to divide by 4, which means we divide the other side by 4. 4's cancel out. We're left with 1b, or b. And 52 divided by 4 is 13. So our base is 13 centimeters. This is our third example, which is a trapezoid. We start off by writing the area of a trapezoid formula, which is area equals base 1 plus base 2 times the height divided by 2. And just as before, we fill out our missing information. Do we know the area? We do. It's 38, so we replace A with 38. Do we know base 1 or base 2? Yes, we do. We know both of them. One is 7 and one is 12, so we're going to replace B1 and B2 with 7 and 12. Do we know the height? We don't know the height, so we're going to leave it as H and bring down the divided by 2. This stays the same. It's still 38. We can simplify this. 7 plus 12 is 19, and H is still there, so it's times H divided by 2. What we have here is 19 times H divided by 2. It's kind of a fraction. It's 19 over 2. H, in order to cancel out a fraction, the inverse operation is to multiply this by the reciprocal. So what I'm going to do is I'm going to multiply this by 2 over 19. And if I do that on this side, I'm going to have to multiply by 2 over 19 on the other side as well. What ends up happening is that 19 times 2 is 38. and 2 times 19 is 38, and you end up with 38 over 38, which is 1. So the way we normally write this out is we just say the 19s cancel each other out, the 2's cancel each other out. On the other side, we're multiplying a fraction. So 2 over 19 is being multiplied with 38 over 1. 2 times 38, well, let's bring down this h first. Everything cancels, so we're left with h. 2 times 38 is 76. 19 times 1 is 19. So if we simplified that, if we divided 76 with 19, we end up with 4. So our height is 4 centimeters. For our final example, we've got a rhombus. So we need to find the missing diagonal, which is this one right here. We're going to start by, again, writing the area of a rhombus formula. Its area equals diagonal 1 times diagonal 2 divided by 2. Let's fill in our missing information. Do we know the area? We do. It's 60. So replace A with 60. Do we know diagonal 1? We do. It's 15. So we replace diagonal 1 with 15. Do we know diagonal 2? We don't, so we're going to leave it as D. And we're going to bring down the divided by 2 over here. Again, you end up with a fraction 15D over 2, which is the same as 15 over 2D. So we're going to try to cancel out these numbers by multiplying by the reciprocal, which is 2 over 15, which means we have to multiply the other side by 2 over 15 as well. The 15 and the 2's cancel each other out. To multiply this out, I'm going to put a 1 underneath it. That way the multiplying looks a little bit cleaner. We bring down the D, because that's what's left over here. 2 times 60 is 120. 15 times 1 is 15. If we simplify that, 120 divided by 15 is 8. So our second diagonal is 8 centimeters, and that's our final answer. So that's how you find a missing length given the area of any polygon.